first thing I want to do today is just talk a tiny bit about the tests. So first of all, some of you guys did really well, which is awesome. For those of you who did not do as well as you were hoping, I will say that there's still good news. And the good news is the tests are only worth 40% in this class, which is the lowest out of any class that I teach at GCC. Tests are worth more in every other class that I teach. But I understand that some of the students that end up taking Math 117 have had very bad math experiences in the past, have difficulty taking math tests. It's this whole big ball of stress. And so that percentage up there is my way of trying to minimize the impact of a bad test grade or two. Up at the top here, you will see your score on this test. The median score in this room was 80.5. That means that half of you guys scored higher than 80.5 and half scored lower than 80.5. The high grade was 100. One person got 100 on this test. The rest of the numbers here, let's make sure we're clear on what it means. Your participation is showing up every day and participating and staying until the end of class. Hopefully you've got 100 here. If you've been missing classes, that's going to be less than 100, but it will go up if you stop missing classes for the rest of the term. That's worth 7% of your overall grade. These percentages are on the syllabus. The homework is worth 20%. Many of you have 100, which is great. Some of you have like an 80 something, which is okay. Some of you have a really low number there. And I want to be really clear. The homework being worth 20% means that each homework assignment that you don't turn in is almost a point off on your overall average. Almost a point for every homework assignment you don't turn in. So it's pretty significant. So if you haven't been turning in the homework consistently, this is a good chance to start turning in the homework consistently. And every time you turn in a homework assignment, that percentage will go up. And your net grade will go up as a result. The projects are worth about 1/3 of your grade. Many of you did quite well on project number 1, so you should see your project 1 grade right there. And then the tests, like I said, are 40% altogether. And then in this blank space right here, you will find a number, which is the percentage that you got right now as if the course were to end today, and then a letter grade. And that's what you would have if the course ended today. Nobody's grade is set in stone. If you have an A, there's still opportunity to drop down to a D. If you have a D, there's a chance to move up throughout the semester, all right? Lots of grades left to come. If you have any questions about your individual grades or your individual tests, please see me right after class. I'm happy to chat with you. And again, I'm not giving the test back for keeps right now, so once you've had a chance to look at it, can you throw it back in the red folder for me? And I will return it for good next time we have class, okay? Everybody put your test back in the red folder. Monday is Columbus Day. There are no day classes on Monday. So the next time we will see each other is a week from now. Yeah. Yeah, just try to hold the tears back.
Well, it's confusing because
night classes meet almost every holiday.
I wasn't sure what was going on with that.
Okay. Next. All right, here we go. Okay, having a look at our calendar. We just finished test number 1. You can see this fancy word that you may or may not know says apportionment. It is the next 4 classes for us. It is the next major topic for us. It's as significant a topic as voting was for us. 4 classes on voting, 4 here on apportionment. And just like voting, we're going to talk about the methods that we can do this thing. And then we're going to talk about some of the problems, like we had Arrow's impossibility theorem and all those fairness criteria. There's kind of analogous things that we're going to talk about for apportionment. And just like voting, there's an apportionment project. That project is going to be assigned next class 1 week from today, and it will be due on November the 4th. I will return it to you with the grade and comments on November 6th, hopefully in plenty of time for you to review and learn and do well on the apportionment stuff on test number 2. Questions on the calendar? Okay. So we've got that, and let's come back to here then. So this is packet number 2, and there's a reference sheet here on the first page. We're going to skip past that for now and go to the next page. Is that page 2 or 3? Page 2. Okay, so let me just put this thing out here at the start. Apportionment is a topic that I have never taught before in my entire lives. You guys are like version 1.0 for me, right? And anytime there's a version 1.0, there's bugs. And so I can assure you that I'm going to be making some mistakes in the next 4 classes. I'm not going to be using the words as fluidly as I did in the first part of the semester. This stuff is pretty new to me. Not only have I never taught it, I didn't know it until I said, oh, we're going to teach it this semester, so I got to go learn it. So again, like I like to think I had a pretty good handle on all the stuff on the first test. I have a solid handle on this, but I'm not as comfortable with it as I was for the other material. So bear with me as we work through this together. Okay, so we'll begin with the intro here. Can we go to Evan? Okay, so let's think about this. If mom just wanted to take the easy way out, what would be the equal way to divvy up those 50 pieces of candy to her 5 kids? Just 10 each, right? And we could just divvy it up equally. But we want to build a reward system in here, and we want to reward these children for doing their work. So mom is going to diligently keep track of all of the number of minutes that these kids worked, and she's going to give out the candy accordingly. So we have 5 kids here. Notice that their initials are A, B, C, D, and E. That's going to make it easier for us. And here are the minutes that they each worked. So who gets the most candy? Ellie, she worked the hardest. Who gets the least candy? Betty. And apparently Ellie at about 300 minutes and Betty at about 80 minutes. Ellie worked like 4 times as much or so she should get like 4 times as much candy if we can work it. So altogether, it's a total of 900 minutes that they've worked, and that's going to be important. What you're going to do now, completely without any other direction from me, is take some time in your groups to try to find a fair way to give out that candy based on the number of minutes that they worked. And we're going to spend a bunch of time on this. So really take your time and thoughtfully work with your neighbors. See if you can come up with a distribution. Okay, so coming back together. We had different groups solving this problem in different ways. Raise your hand if you ended up using a proportion, which is a fraction equals a fraction. So at least one table right here in the middle using a fraction equals a fraction. Raise your hand if you use percentages. This table here, that table in the back used percentages. You guys did too. That seems reasonable. This table did something very fancy based on the reading. They found this thing called the standard divisor, and they divided, what was that standard divisor in this case? 18? Yeah, about 18. You guys in the back there also found 18. So what 2 groups ended up doing was figuring out that if you take 900 minutes and you divide it by 50 pieces of candy, then what was it equal to? It was 18 minutes per candy. For every 18 minutes that you work, you get a piece of candy. And so you can just take that 18 and divide it into each of these number of minutes. Right? That's a really nice way to do it. So lots of ways to do it. And if I've copied this down right, 8, 4, 10, 11, 16 is like the standard kind of answer. There's a couple of problems here. One problem is that those are not the exact numbers. Right? There were decimals that we just either rounded or cut off or something like that. And the difficulty here is that maybe Alan didn't deserve 8. What did Alan actually deserve? Anybody have the decimal? 8.33. 8.33. So the difficulty here is, can I cut the candy into like perfectly equal thirds? I can't, but even if I could, I mean, it wouldn't be exactly right. But these candies are indivisible. And we're going to look at another example on the very next page where it's really clear. There's no cutting involved. Like you have to give out whole numbers of candies, whole numbers of whatever. So this is what's known as an apportionment problem. You come up with the thing that you think is fair, but what do you do with the extra stuff, the decimal stuff? And in this case, when we kind of round everything in the natural way, we only have given out 49 pieces of candy, and we've still got 1 more to give. So a couple of tables wanted to give it to mom. That seems reasonable. She had to do a lot of logging of their hours, so she deserves something. But basically this section, these next 4 days, are all about what do you do with the extra stuff. You can't cut the candies up, and you might not have given them all out when you do things in the natural way. All right, Alicia?
Well, when we did it, we got like.
Yeah.
So like instead of 8.3, we ended up getting 8.5. But we ended up rounding depending on how many minutes they work. So like Ellie rounded up to 17, Doug rounded up to 12, Connie was at 9, Betty was 4, and Alan was 8.
Yeah, so in this case, it does add up to 50, and you guys ended up with slightly different rounding things than over here. So great.
We
Percentages. Yeah. So that's what this major topic is about, is how do you divvy up candies, except it's much more significant than that. So let's take a look at a picture that we've actually looked at already this semester. What do all these numbers represent? Those are electoral college votes. And we looked at this when we started talking about weighted voting systems. So up here, Massachusetts has 11. That's 11 people, right? There are like physically 11 people that are going to represent the state of Massachusetts' will every 4 years when it comes time to elect a president. 2 of those people are different from the other 9. 2 of them have what role? They are senators. Yes? How many senators does California have? Also 2. Every state has 2 senators. What about the other 9 people out of our 11? Who are they? They're representatives. We have 9 people in the House of Representatives. How many does California have? 53. Everybody has 2 senators plus, and then the number of representatives changes. How come California has way more than we do? Population. So we give out these seats, we decide, and I mean, like our forefathers have decided, and I'm sorry to use a sexist word, but the fact is they were all guys. Our forefathers decided that we were going to give out these House of Representative seats based on population. Fair enough. But do you see the problem? Do you see that this is going to run into the same issue as we did with the candy? Like the Massachusetts population, I don't know it off the top of my head. We'll say 5 million. Okay, and California's population, I don't know what it is, 20 million. But like it's not going to work out perfectly, right? Like if we just start divvying up, there's 435 seats for the House of Representatives. If we just start divvying them up, doing the same thing we did with the candy, we're going to have decimals, and we're going to have rounding, and we're going to have some people that end up being the winners because they got rounded up, and some people that end up being losers that got rounded down. And so the candy, even though it's kind of a silly example, this is what it comes from. It's like, how do we figure out how many people each state has in terms of being representatives? And so that's what the major apportionment problem is. It's this right here. So let's take a look on the next page, and we'll have Mary. Okay, thank you. Same idea, but instead of candies being based on how much time you spend working, now we have seats. 250 seats in Congress based on your population. But it's the same basic idea. So our job is to fill in this bottom row, just like you guys did with the candy. So we're going to do this in like the correct way, and then we'll come up with all kinds of different ways to handle the decimal parts, to handle the rounding issues. Okay, so we'll give you actually 3 different ways to figure out like the normal way to apportion these seats out. First, we'll use percentages. Okay, so how do we use percentages here? Well, let's look at state A here. They have 1 million and change in terms of their population. Total population of the whole country is 12.5 million. How do I calculate a percentage there? We're going to divide. So we're going to take, so this is just now for A. So we're going to take the 1646 and divide it by the 12.5 million. And what do we get here when we do this division? Point what? 13168, that's good. As a percentage, how do we convert? Yeah, 2 places to the right. So we'll say 13 point, we'll round that to 1317. We're not going to do it for all 5. We're just going to do one, and you could do the same calculation for all 5. But what does that mean? It means that 13% of the entire country's population lives where? Lives in A, lives in state A. So how do we figure out how many seats state A deserves?
13% of the 250.
They deserve 13% of the 250, yeah? So that's their population, and then we can just calculate 13.17%. How do we do 13.17% of 250? How do we actually calculate this? We're going to multiply. What times what? Yeah, so the 0.13, like we changed it to a percentage so we could talk about it a little bit easier, but decimal is really the way you use it to calculate. So we multiply these two things, and what do we get? Okay, so we'll say about 32.92. I know the next number was a 5, but we rounded someplace. That wasn't really a 1.7. It was really a 1.68. So I think that it rounds down. It doesn't go up to 9.3. I think it stays at 9.2 if you use a little more. Well, I mean, ultimately, we're going to have to come up with a way to handle it. Whether it's a 9.2 or a 9.3 doesn't much matter. We need a rule to figure out what to do with it. Well, what I'm going to do is I'm going to write it just as it is. And then the next 2 weeks of our class is going to be to decide what do we do. Does it go up to 33 or down to 32? So it's a hard question you're asking, and that's what we're after. So 32.92 goes there. Any questions about that? Okay, and you could do the same thing for all 5 of the states. Let's try a different method. We're going to use a proportion instead of using percentages. It's going to be kind of equivalent. Let's look at B's number. So B is 6936. Let's put this down here. So let's take a look at for B. It was 6936. They have a certain amount of the population, which if I'm remembering is 12.5 million. Whatever part of the population lives in B, they should have the same part of the 250 seats. So what do we think of that? X is the number of seats they deserve. They deserve a certain fraction of the 250. It's the same fraction as the population fraction. What's the best way to solve that equation for X? So cross multiply is one way. Right, just multiply across the diagonals. There's actually a slightly more efficient way. What's the only thing that's near the X right now? The 250. As soon as I move the 250, then X is by itself. So how do I move that 250? Is multiply both sides by 250. So I'll put in another color here, times 250 here for the sole purpose of immediately canceling. And then times 250 over here, that's just kind of bookkeeping. We're required to do that because we did it on the right. Okay, so if you just very carefully type in on your calculator 250 times 6936 divided by 12,500, then we will have X. Thank you. Questions on that method? No, here, I mean, ultimately we're just using a calculator, but really that 250 is upstairs if you want to know where it actually is. It's not top and bottom. Yeah, there's a hidden 1 to really separate. It's on top. Okay, so 138.72, that is the right answer for the number of seats that B gets, so we'll put it in here, 138.72. And now we're going to show you one final method that we can use. And it's going to seem a little bit involved, but it's actually the most efficient way to do things, even though it seems unnatural at the beginning. So let's try this third way. So we're going to use the, we're going to do one of these two again. I'll do the first one again just so that we can verify that this weird way we're about to do actually gives the same answer, the right answer. So 1646, that's what we're going to use, and we're going to hope that we get 3292 as the answer. So 1646. Here's what we do. We're going to find something, we're going to define something called the standard divisor. It's a fancy name for something that's not all that hard to do. We take the total population and we divide by the number of seats. Total population divided by number of seats. What was the total population? It was 12,500,000. Total number of seats? 250. Notice this has nothing to do with any individual state or their population. This is just this generic thing that you figure out for the whole country. Now we do this division, and what do we get? 50,000 is right. I'm going to put units here. 50,000 is the number, and that's all that we need. But the units, I think, are going to help us. That 12,500 was what? People. So this is 50,000 people per 250 was what? Seats. So it's 50,000 people per seat. Every 50,000 people that you have in your state, you get another seat in the House of Congress. Just like with the candy. Every 18 minutes you work, you just earned yourself a piece of candy. All right? So if every 50,000 people means something to you, then if we're focusing on state A, or 1.6 million people, how do I find out how many seats they get? Divided by 50,000, right? Question is, how many 50,000s, how many groupings of 50,000 people do they have? Well, that's a division problem. So yeah, we take the 1, 6, and change. So we go 1, 6, 4, 6, and change. We divide it by the 50,000 that we just found. And lo and behold, 3292. And even though it's a little more complicated, at least in the idea, the application is way faster. Because if you wanted to do percentages, then for every state you would have to just start over and do a brand new percentage calculation. If you wanted to do proportions, for every state you'd have to do a brand new proportion, solve using a little bit of algebra, and then type the thing in. But here, once you've found this thing called the standard divisor, it's really easy. You just take 50,000 and put it into each one of those different states' populations. It's quick. So what I'd like you to do with your neighbors is make sure that you get the right answers for the rest of it. Maybe confirm B, the answer we got before, and then fill in the numbers for C, D, and E. Okay, so doing this standard divisor business, you pay an upfront cost. You have to do that weird calculation to find the standard divisor. But once you've got that, then it makes it really easy to find all of the apportionments, all the ways to divvy up these seats. It's really fast. And then we add all these things up, and if we had written all the decimal points, then I can tell you what we're going to get. You can check on your calculator, but what do we get if we add all those things up? It's 250. It's going to be perfect. Now, I don't know whether or not it's perfect the way that I've written it here because I rounded after 2 decimal places, but if it's not perfect, it might be like 249.98 or something like that. And if we wrote more decimal places, it would get more and more perfect. So this is perfect. We have given out exactly 250 seats. The problem is I can't give 32.92 seats, right? I mean, even if you could argue the candy is something you could cut up, definitely can't cut up these seats in Congress. So 3292 could make it 33, could make it 32, could do anything with it. But the question is, how do we handle all the extra stuff? Yeah.
Like A is 32.92, and then B is 208.
Yeah.
Mm-hmm.
Right.
And then whereas in D,
Mm-hmm.
You could kind of make a case that, you know what I mean? Round up and down.
Right. round up and round down. So what if we just decide to round everything up? Well, we'll round everything according to the regular rules. So this becomes, you don't need to write this, but this is just kind of something to, so that's 139, down to 3, 42, 14, 20. Okay, add those up. So we round them all in the natural way and we add them up. And what do we get here? 251. Well, that's too bad. Because the natural way of rounding didn't happen to give us a way to divvy up the 250 seats. Sometimes the stars align and you just round in the natural way and everything will work out perfect. But usually it doesn't. So again, this is the problem we're faced with, is what do you do? Our natural way to round didn't give up 250 seats. It gave out an extra one. So we got to make one of these guys a loser, right? And the question is, how do we do that in a fair way? Okay, so let's move on to the next page. It says we can calculate the exact number of seats, but we can't give a partial seat, so we got to figure stuff out. All right, lots of vocabulary here. We'll go to Brandon for the states. Okay, so we had 5 states in that last one, A, B, C, D, E. They're not always states. Who were the, quote, states in the candy example? It was the kids. The kids were the ones waiting to be given something. Here the states are waiting for seats in the Congress. The kids were waiting for candy. Okay, let's go to Casey, the seats. Okay, identical because they're all considered equal. There was no seat that was worth more or less than any other, and not divisible. Can't cut them up and give out partial seats. What were the seats in the kids example? Was the candies. That's what we were giving out to these kids based on how they worked. We'll go to Griffin. Yeah, go ahead. Okay, so apportionment methods. We're going to learn actually 5 different apportionment methods, 5 procedures that will allow us to give out these seats and not have anything extra and come up with a way to handle the remainder stuff. We're back to Sam. Okay, so standard divisor is one that we just did before. It was the total population divided by the number of seats. All right, so I'm a big fan of like little mnemonic devices to help me remember stuff, especially for this because I'm very new to this myself. But P and S, I know not a lot of people write letters anymore, but PS is something that you could put at the end of a letter, right? So that's how I remember what I'm supposed to divide. It's population divided by the seats, okay? If you really want to, you can get the word total in there, total population divided by seats. Anybody see the movie Office Space? Is this the acronym? It's like this thing called the TPS report that the one worker didn't have, and then the manager came in and said, oh, I'll give you the memo. We need to attach the TPS reports. I don't know what the TPS report was, but it was this running joke in the movie Office Space. So if that means something to you, then great. If not, make up something else that TPS will have meaning for you. Okay, we'll go back to Stephen. Standard quotas? Okay, that's what we just did. Technically, state A should have gotten 32.92 seats. That's the standard quota. Standard because it's like the only reasonable thing to do as a first attempt. Quota is just something you fill, right? Like a quota is something that gets filled. So they should have 32.92 seats. That would be fair, but we can't give them that much. But that's how we start. Okay, and then moving on to Chad. Mm-hmm. Yeah, that one. No, upper and lower. Okay, we didn't do those here, but 33, did we have to round up or down? We rounded up for that one, so we're going to call that the upper quota. How about the 3? That was rounded down, that's the lower quota. Come back to 3292. Forget regular rounding rules, just round down. What does it become? 32. So 32 is the lower quota, 33 is the upper quota, the right number is someplace in between, all right? So upper just means push it up, lower means push it down. Forget about rounding at 0.5. We can just always go up or down, and we have names for those two things. Okay, and then we're here to Jeremy. Wheel. Okay, so we're going to talk about this thing called Hamilton's method. Now we're going to come up with the names of a lot of people that you guys have heard of. We talked about the forefathers of our country. They were really introduced and they were really interested in solving this problem, and their names are attached to a bunch of these methods that we're studying. Okay, so instead of reading the directions, let's actually just go through the calculation and then we can look at the directions up above. All right, so those are the populations that we just saw for this made-up country of Parador. And then 3292 and these other numbers are the ones that we wrote down, yes? Okay, so we've seen these numbers before. Again, the question is, how do we get to the magical number 250? How do we handle all the extra stuff after the decimal point? All right, so first thing we're going to do is fill in lower quota and upper quota. Again, this isn't like rounding traditionally. This is just round down and round up. 3292, oh, sorry, I said upper quota. We don't need upper quota, just lower quota. So 3292 rounded down is 32. 138.72 is 138. Go ahead and fill in the rest of these. And once you have them all there, add them up and fill in the total. What's the total? 246. Next thing we're going to do is look at this funny word called residue. You guys have heard of like if you're cleaning your bathtub, there's like this residue on the tub, right? It's the leftover stuff that's just sitting there, right? Okay, the residue is the leftover stuff. So of 3292, 32 is the lower quota, but what's the leftover? Is the 0.92 with the decimal point. That's the leftover, the residue. So fill in the rest of those. And when you're done, add up to get the total. If you're on the ball, you should be able to figure out the total without your calculator. What do we get when we add these up? 4. Is that a surprise? No, of course it's 4. Because we had 246, and the 4 that we were missing are right here in the residues. So there's a 4. Next thing we're going to do is talk about the order of the surplus. And this is essentially the heart of this method. If somebody's going to get bumped up, who's the most deserving of these states right now? A is most deserving, right? Because they're at a 0.92. They have the most. So if we're going to give a seat to somebody, it feels like A should get the first seat. Who's the second most deserving? Is maybe D, right, with a 0.82. So this is how we could give out these 4 remaining seats. Now I'm going to write in a couple of different things here. I'm going to say, okay, so the first, I don't know how to write it. First most deserving person is there. Second most deserving we said was the 0.82. Third most deserving is F at a 0.76. Fourth most deserving is B, and I'm not going to put fourth, although I could. I'm going to put last to indicate that I'm stopping. There's no reason to look at who's fifth most deserving. How come? There's only 4 seats to give out, so there's no point looking at who's the first loser. I mean, like it doesn't matter. So we'll just stop. I'll put the word last there. So if you feel like putting those things in, then put them. I'll put in another color here, an alternative. What you could do is check mark. Okay, that's the first guy. That's the second guy. There's the third one. There's the last one. And just write the check marks. That's okay with me too. We're going to be using Excel. It's a spreadsheet program. I'm going to put something in here that maybe isn't super natural to write down like as a human. But in terms of spreadsheet language, it makes a lot of sense to write it down. I'm going to put 1s for everybody that gets something and 0s for everybody that doesn't. So it's 3 different alternatives I'm putting there. You can use whatever is most comfortable for you, but I've got reasons for putting all 3 of them up there. So we'll just use all 3. And 1s and 0s, that's a computer thing to do, right? Can you, remember how we had this total column here on the right? Can you add the check marks? Like, does it make sense to find the total value of the check marks? You can count the check marks, but you can't really add them, right? Can you add up the word first, second, third, and last? No. Can you add up 1s and 0s? Yeah, what do you get when you add those? 4. So there is something kind of reasonable. That 1 is saying this person, this state gets another seat. This state gets 0. Okay, and then the final apportionment, which is our ultimate answer here. We had 32, but this state got another seat. So how much do they have? 33. That's their final apportionment. How about B? There's 139. They had 138. They got 1 more. How about C? It's just 3. They had 3. They didn't make the cut. They got 0 more, so they're still at 3. Go ahead and fill in the last 3 columns and then calculate the total. We have this right, 42, 13, 20. And the total, 250. Hooray. We made it work. I mean, like we had 4 seats to give, so we gave 4 seats. And it seems reasonable. One other thing, again, the green numbers, the 1s and 0s are very computer speak and maybe not so natural for us, but there is something kind of nice. How can you get the 33 thinking about the 1? Add 32 and 1. Yeah? That's 33. Does it work with the 0? Add 3 and 0 and we get the 3. So I put it there again because we're going to be using Excel on this project, and this is a very Excel thing to do. It's just say, okay, we're just going to add the number in the first row with the number in the third row, and whatever you get, that's the total. Questions so far? Okay, so next page. And who's our reader now? Can we go to Kate? Okay, thank you. So basic idea here is you've got 12,500 students at this school, and there's going to be 250 faculty positions, but they got to figure out how many faculty should be teaching in each of the different schools. You know, you could have like one person teaching agriculture and 1 business and 1 education and 1 humanities and 246 science teachers, but that's probably not going to serve the student body very well, right? And so how do we decide how to divvy up those 250 faculty positions? Well, you look at how many students are enrolled in each school. The more people in the school, the more faculty they should have there to support them. So your job is to do the calculation that we just did, which means you're going to make your own blank table, and the table was left out here so that you'd have an opportunity to create the table. So using the example that we just did, go ahead and make your blank table and then start to fill in all the numbers, all right? Okay, I think we heard a couple of, well, I heard a couple of tables talking about the pros of Hamilton's method. So what have we seen about Hamilton's method that's nice? It's easy. Yeah? Anything else about Hamilton's method that we like?
It's kind of fair.
Seems fair. It seems like a really fair way to give up the seats, right? You just figure out who's the most deserving by looking at the residues. So easy and fair. So it turns out that there are a bunch of drawbacks of Hamilton's method that make it terrible. So we're not going to use it. but in the next few classes, we'll talk about some improvements to it. At the moment, it's really not clear what the problems are, but we'll see them soon enough, okay? So here's what I want to do now. I mentioned to you that we've got a project coming up. It's going to be assigned officially next class, but let's spend the 10 minutes or so that we have here together talking about this project. So first of all, if you don't know how to log into Moodle, see me right after class and I will tell you, because in order to gain the files that you need for this project, you got to go to Moodle. This is a project based on Excel, and I can't hand you an Excel file. You need to go download it on our Moodle page, all right? So if you go to Moodle, you will find a list of courses that you are taking, and probably you're not lucky enough to be taking like 5 math classes like I am, but you'll find our math class, Math 117, and you click on it and it tells you you've timed out, so then you sign in again. And here. All right, so if you go into our Moodle page, you will find a list of things called project materials, and if you go to project 2 materials, you will find 3 documents, 1, 2, and 3, and you can download all 3 of those at home. I have already opened some of them up, so let's open up the project itself, which is this guy right here. This is what the project looks like. It's this. It says what you're going to do is program Excel to apportion the 435 seats in the U.S. House of Representatives to the 50 states using each of 5 methods that we learned in class. We just learned Hamilton's method. That's method 1. We got 4 more coming. They're all down here, all right? So don't worry about all the details. But here's the idea. Would you want to go through the calculation that we just did for Hamilton's method, but for all 50 states? No. So using the power of the computer, we're going to have Excel do this calculation very easily. Caitlin has gone through the trouble of actually typing in all the states' names and putting all the populations. That make it easier for you. But there's nothing going on in here. What does SQ mean? Standard quota. That was the 32.92 that you found in that last example. LQ? Lower quota. Residues we talked about. Surplus we talked about. And then the final apportionment is what you guys ended up with as your final answer. Standard divisor we talked about as well. But the issue is that all this stuff is blank, and you need to populate it with formulas so that Excel can fill it in with numbers, all right? Now, I'm expecting that many of you are not super proficient with Excel right now, and that's okay, because we will give you all the tools that you need in terms of Excel. So first, there's a list of commands that you might end up using during this project, and we're going to talk about some, if not all of them right now. So what I'm going to do is show you, where is it? Right here. Here is another example. In fact, are these the same numbers we just had with the Parador? 988, was that the last? Yeah. So this is the example that we just did. And I'm going to now show you how to use Excel to get the numbers that we got. So you can open to the previous page, wherever we did the Parador Congress. And let's talk about it. All right, so what goes right over here in this cell is the total. It's 12.5 million. But I don't want to type this thing in. In fact, I don't want to type a single number in here. I want to type in commands that say, hey, Excel, here's what I want you to do. So here's the command. You type equals, you type SUM, it stands for sum. You hit parentheses. And then you say, okay, Excel, I want you to add up these numbers right here. And it is literally a click and drag. So I'm going to click anywhere in this cell. I'm going to drag to the right until I land on the last state. I'm going to let go. You can notice Excel has typed in for me, oh, you wanted B2 to G2? You guys see the number and letter things happening? So B2 all the way up to G2. You can type in the closing parentheses if you want. I'm lazy, so I just hit enter. And we get 12.5 million. Super. Easy? Okay. Next thing we needed was the standard divisor. What divided by what? It's 250 seats. This 12.5 million divided by the 250 seats, right? So we come down here, I say equals. I don't want to type in 12.5 million. So you can just click on this thing, or you can type in H2, or you can just click on it. There you go, that number. Divided by, in this example, there were 250 seats. What was the standard divisor here? 50,000. There it is. Okay, not that big a deal so far. Standard quota. How do we find the standard quota for A? Divide what by 50,000? Population. So I hit equals. That's really important. If you don't hit equals, it's going to yell at you. You hit equals to tell it you're typing in a formula. You click on this cell right here. I want that cell. divided by is the slash key on the keyboard. This cell right here. Enter. Is that the right number? Super. By the way, I'm expecting that some of these commands are going to be too fast for people that really have no experience with Excel. So here's the good news. The good news is, number one, I'm recording this. So you can see everything the mouse is doing and everything that I'm typing. And so later on, if you want to, you go into Moodle, you download this class number 11 thing, and it will pull up exactly this document blank, and you can just mimic everything that we're doing here and make sure you've got it. Number two, Caitlin has written up this wonderful Word document with a different set of numbers in it, where she has taken a million different screenshots, and she tells you exactly how to do everything that you need to do. It's really detailed. There's the sum, B2 to E2. It's all written out, all right? So you got the video that I'm making now, and you got this Word document. That Word document exists right here on Moodle, okay? All right, moving right along. Here we go. This one right here. Okay, so here's the power of Excel, is that if I wanted to get the standard quota here, what would I type in? I'll type in that population divided by the 50,000. All right, but I can just say, hey, Excel, do the same thing that you just did here, but do it over here. Do it the rest of the way. And so in the lower right-hand column, the corner of this box, see how the cursor changes? If it changes to that little plus sign instead of the big fat plus sign, then I can take and I can drag. Just to there. Okay, I made a mistake someplace. But if we fix that mistake, then all those numbers are going to fill in perfectly. So I'm going to do, where's the undo arrow right there? Here's the problem. When I said divide by B10, okay, that was fine. If I click this to the right, take a look. It knows that I'm doing, what am I doing wrong? Here we go. So taking a look up here, it says C2 divided by C10. It knew I wanted C2. That was the right thing to do. But then it went over to C10, which is blank. That's why it's yelling at me, because I'm dividing by a 0. So what I need to do instead, let's undo, is right in here, instead of having B10 being this thing that maybe it's going to think, oh, you just want to keep moving to the right, you hit the F4 key. Kind of a funny command. All it does is put in $signs, but those $signs are Excel's command to say stay right here every time. Don't move to the other squares that are nearby, just stay right here. So I'm going to hit enter. It's going to stay at 3292, but now it's got $sign, which means when I move to the right, it still has $signs on it, and it stayed at B10 instead of moving over to C10. And so we can take this guy and we can drag it all the way to the right, and we have that. And then we can do the total that we had before. I can just drag down. There's my total. Lower quota equals, there's a command called round down. I want this number rounded down to 0 decimal places. Is 32 the right number? That right there is why we're using Excel, is because you can drag and drop. And it'll just copy the whole formula down. What was the total here? 246, right? This was the one with 3 extras. Okay, the residue equals, what do I do to get the residue? Well, couldn't I take this number and subtract this number? Isn't that the residue? It's just the stuff that's left over. Drag this guy to the right. Sum total, magically 4. Okay, the surplus is the complicated one. I realize that we are running very short on time. This will be the last thing that we do. Again, you have the video here, but here's the command. It's kind of complicated. Okay, if this number right here is greater than or equal to, how many seats were we giving out here? We were giving out 4 extras, right? That's what we're after right here. If it's greater than or equal to, and now there's this command that says, all right, the largest number in a list. The largest number in this list right here, but I didn't want the largest number, I want the 4th largest number. That one says, yes, it is bigger than the 4th largest number. Drag to the right. What did I do wrong there? B5 to G5. Oh, these guys should have had the $signs in it. That should be okay now. Okay, tell me if those are in exactly the right spots. That command is really complicated. It is explained in detail here in this Word document, all right? So I'd encourage you to go home, log into Moodle as soon as you can, Play around with this a little bit. It will be assigned officially in 1 week.